Well, the International Space Station is helping prepare us to carry out deep space exploration missions of the future to destinations like an asteroid and ultimately to the planet Mars. Much of that work here at NASA to prepare for those missions is being done under the direction and guidance of the agency's Human Exploration and Operations Directorate, which is led by Associate Administrator Bill Gerstenmaier, who joins us here in the International Space Station Flight Control Room this morning. Nice to have you here.
It's great to be here.
Tell me what you're doing here in Houston, part of this presentation you're a part of today.
Yeah, I get a chance today to talk to the teams here in Houston about the future and our plans for exploration. We have many things ongoing right now. We have the space station, which is really the first piece of space station activity or exploration that we're doing. We call that kind of the Earth-reliant region. As you can see last week when the crew came up on the Soyuz, a 6-hour jaunt from the Earth to the space station is not too tough, and we get there. If we have parts we need to bring back, like the suit that you described earlier, that we were able to deliver that on the SpaceX Dragon vehicle. But as we think about moving human presence out into the solar system, we have to start breaking those ties with the Earth. So we kind of move from this Earth-reliant region and the space station and activities that we do there to a region we're calling the proving ground of space, and that reaches out somewhere around the moon to kind of the cislunar space, or the region between the Earth and the moon.
Right.
And the idea there is to gain experience in operating kind of away from the home planet, where it now takes 5 days potentially to get back if something doesn't work right. You have to do rendezvous potentially on the other side of the moon, where you have to do autonomous rendezvous without the ground teams being able to watch and monitor things. We also get a chance to look at using things like lunar gravity assist to maneuver spacecraft around. We get a chance to kind of practice things that you're going to want to go do when they really become more serious as you move into kind of this third region.
Even further away.
Even further away. And so if you think about the Apollo program, what we did in Mercury and Gemini is we did a series of flights that really prepared us for Apollo.
Right.
We did EVA activities to prepare for those. We did rendezvous proximity operations in both lunar vicinity and also on the Earth, or in the vicinity of the Earth. So we need to do those same things in this proving ground region of space. So that's kind of our next location. We will do that with the asteroid redirect mission. So instead of going out to an asteroid, the intent is to bring an asteroid back in around the moon, and then allows us to go practice in this proving ground region of space. Then eventually we get to this further out region, which we call essentially Earth independent. So by the time we're there, ready to do Mars class missions, we need to be really independent of Earth, where our crews can really operate. We've got the risk level up. We understand the operations and techniques. But the cool thing is really all this stuff really starts back at the space station. So the things you talked about today, where the crews are looking at how the biology system of the human changes in the microgravity environment, that's going to be obviously important to see how the microbiome of the human changes as you're there for a year. So you want to learn that here. If there's something unique that's not quite right with the way things work, you want to know now.
Yeah.
The crew's working with the veggie, which is interesting. Before we just did plant research to grow unique plants. Do we understand the genomics of the plants? And we were trying to understand
not trying to feed ourselves.
Not trying to feed ourselves. So this is the first time we're actually growing plants with the intent that we can actually eat these, and this will augment the crew's food supply, which will be intriguing and interesting. So it'll be neat to see the images from station, see how big the plants are growing. This time we'll freeze these plants. We'll bring them back to the Earth to just make sure that there's nothing from a biological standpoint that's occurred to the plant that would be problems if you went ahead and ate it. So it's kind of one quick check before we do that, but then the crews will essentially now have potentially a source of fresh vegetables and lettuce to augment their daily diet, which I think will be interesting to the crews here, but absolutely mandatory as we go on exploration class missions.
We try to talk about that a lot, and how the work that's being done on the station is building towards these other things, and it's the other things, it's the going to Mars that tends to get people really excited.
Yeah, I think, when some people kind of go, well, why Mars? Well, part of the reason for Mars is it has some basic capabilities of things that we can use, so we don't have to carry everything with us. It has a carbon dioxide environment or atmosphere, so we can potentially pull oxygen out of the atmosphere with like a Sabatier reactor, very similar to what we do on space station.
On the station.
And so we can pull that oxygen out compress it, and then we have a source of oxygen to breathe, and then also potentially oxygen was an important component of rocket fuel to potentially get you off of Mars when it's time to come home. We also know Mars has a lot of moisture. If you look at the Phoenix lander in the northern poles of Mars, there's moisture there, water, so we've got water which we can use. We also know there's nitrogen present in the Martian environment. That's an important component of growing food. We believe the Martian soil could potentially support growth of plants. We'll maybe get a chance to look at that in some other investigations. And we have a radiation monitor now actually on the rover, Curiosity rover, that runs around and monitors the daily radiation environment on the surface of Mars. So the point is, Mars has many things that we can use to make our journey tolerable to go those distances, so we don't have to carry everything with us. So we'll spend the next couple of years investigating things about what we can use in the Martian environment to prepare us for eventually going there. So when you think about it, we're really kind of moving human presence from the Earth essentially into the solar system, and one destination, or one of the first destinations, will be Mars after we get through this kind of proving ground region to make sure we're really ready to go to commit to those Mars class missions.
And we need a ship to get there. Where are we stand right now in developing the spaceship that'll take us to Mars?
Yeah, this last week was a tremendous event for the Orion capsule. They just attached the heat shield to the bottom of the capsule, and that's the largest heat shield we've ever flown. That'll be flown on this exploration flight test in December of this year, and progress is moving really well. You go down to the Cape, and it's exciting to see a real space vehicle there. It won't have crew on board, and it doesn't have life support, but it is really a work of art. The computer systems have all been checked out. It will now, the service module is on. It'll get mated, or excuse me, now that the heat shield is on, it'll get mated to the service module. They'll do some structural testings. They'll do some more final electrical check, and then towards the middle to end of July, it's ready to be turned over to the launch vehicle, the Delta IV, that'll launch on this fall or this December. So it's a pretty exciting time for the Orion team. When I do the event today, Mark Geyer will be there representing the Orion team, and they're really excited. I think I can see that excitement that comes from all of us as we prepare for a launch, and you see those many years of work coming to culmination in one of these really major events. So this heat shield performance test and returning at 80% of lunar velocity will be a really dynamic test coming back.
Interesting to see.
Yeah.
Now, we're also working on developing other crew vehicles, not to go to Mars, but to closer locations. Where are we right now on those?
Yeah, where we are right now is we're looking at the next generation of crew transportation vehicles. We have a procurement out. Then we have companies that have given us proposals for that, and teams are off evaluating those proposals. And our intent is to choose a commercial crew provider sometime in the August-September timeframe, that one or more commercial crew providers in the August-September timeframe that will essentially be that next generation of low Earth orbit transport to and from low Earth orbit. So again, Station is a very unique facility in the fact that it allowed us to do the cargo flights that we're seeing now commercially. We acquired those in a very different way than we have before. We're typically NASA owned the vehicle. Now we're essentially just buying a service to transport cargo. Right. And then now we'll be getting ready to go essentially buy a service to transport crew. And it's an exciting time to see these new providers come online, bring some new ideas, take advantage of much of the research that NASA's done in the past and put it together in a vehicle that they can use to service NASA's needs, but then they can also use it for their own needs. And so it's a pretty exciting time. And Station also potentially can be an innovation engine. It can let commercial companies experiment with microgravity and see how it can affect the research that they're doing today. So, we know bacteria mutate differently in space for some reason. So could pharmaceutical companies use that to potentially find new drugs or new vaccines? So we're trying to expose terrestrial pharmaceutical companies to the environment of space to see if they can use those unique properties in the microgravity environment to have them gain a research advantage over companies that are not doing research in microgravity. So maybe they will come online and say, hey, we really need to do this research. So then it's not just kind of the governments pushing research in space. Now terrestrial companies have a real need and they really want to go to space. So we see that in the pharmaceutical area. We see it in new drug testing. We'll fly some rodents on SpaceX, the next space SpaceX flight this summer. And those rodents can be used kind of as a pass-fail test to see if bone loss medication is effective, because we know our crews lose bone. So you'll get a very quick answer whether this drug is effective in controlling those things. So our job is to expose essentially what we see every day in space and unique properties to a much broader community here on the Earth, and we use space station to do that. And then they've got cargo established through their providers, and they'll have crew provided also. So then eventually someday they could have their own space station as NASA continues to push that edge and continues to keep moving humans further and further into the solar system.
Very exciting to be part of it too. Thanks for giving us a couple of minutes.
Well, thank you very much.
Today. Bill Gerstenmaier is our NASA Associate Administrator for Human Exploration and Operations.